Hey guys, welcome back everyone. Today, I'm going to create another educational recording video once again here on brilliant.org. As many already know, today is Sunday, so long weekend is coming to an end, and starting from tomorrow, Monday, like I have university semester production week. Part of my engineering project is going to be absolutely busy, so this is my last recording beforehand to get some preparations with myself. Yes, so here on brilliant.org, yes, I'll start showing this programming in CS, speak the language of computers. Is what I'm going to continue with my recent exercise activities. This one, algorithmic thinking, the one I'm displaying with a pointer here, so I'll click on it now. Yes, that's right. This is algorithmic thinking. Remember, its objective is to master the fundamentals of designing algorithms, the key to solving problems with computers. So here, I'm currently at level 2, prioritizing shorter durations. Previous chapter completion was finding and algorithms limits, and now level 2 final review is what I'm going to demonstrate to all of you with some presenting lots of key questions I will be encountered along the way. This level review, my final set point for level 2. So I'll click the start button to begin. Right, I've just entered. Oh yes, finally it's ready. Lots of questions to be encountered along the way, but let's get this started. Question number 1. Construct a valid schedule which satisfies all the criteria here. No conflicts. Every rejected flight conflicts with an accepted one, and no accepted flight can be replaced by a shorter rejected one. Let's see. I think like standing order, so which one it should be? I think there are lots of different options, so if I start clicking here, this conflict, this doesn't, this simply doesn't, so this, and then this, right? I think that's the answer. Let's check. Of course, that's correct. Okay, let's click on why. Yes, here. Schedule satisfies all three criteria. C is larger than B, but replacing C with B will create a conflict with A, which is shorter than both. A, C, and E. That's all correct. Like I select these three, and they are also truly the right thing. Like not replaced by shorter rejected ones, so can't be B and D because like less options to choose. Wait, I'm not going to explain anymore. Wait, continue to the next. Question number 2. Okay. Construct a valid schedule. Satisfy all criteria. Again, this is slightly different, although the same instructions given. Let's see. I think these three would meet the criteria, right? Not conflicting. Other two would conflict with the three, so let's check. Yes, that's correct again. Let's click on why. Yes, explanation tells us that this schedule once again satisfies all three criteria. E as the same letter as C, replacing C with an E, create a conflict with D, shorter than both. So yes, C and E can't match, so only these three are correct. Okay, I got it right, didn't I? Anyway, continue. Question number 3. Construct the schedule that this algorithm creates. It goes through the flights from left to right. So here, set accepted to for flight in flights, no conflict, flight accepted, then accepted. Only accept if not conflict with each other. So like this, not this because conflict, so these two are correct. Let's check. Of course it is. Let's click on why. That's right. The explanation tells us the algorithm considers meetings in the order A, B, C. It's only select meetings A and C cause B conflicts with A, so rejected. Simple explanation, to be honest. Continue. Question number 4. Okay, select the counterexample. Prove that the algorithm doesn't solve this problem. Oh, These both instructions, wait, counterexample, which one? No conflict accepted and accepted. No accepted flag can be replaced by a shorter rejected one, I know, so two shortest must be correct. Is this left or right? Okay, I'm a little bit confused. So this problem. Wait, seems like I'm stuck a little bit. Let's consider again. Wait, this one, wait. I'm thinking a little too long now. Fine, flies, not conflict. Flight accepted. I think this is a counterexample. Let's check. Of course, likely correct. Sorry, like I was thinking a little too long. My head's been interrupted. Let's click on Y. That's right, this one. No accepted flag can be replaced by a shorter rejected one. Of course, A can be replaced by B, so that's only the third criterion. So this is false, although it met all of them here. Right, that is likely correct. Like a little bit confused between the two, but anyway, continue. Question number 4 this time. In which instance does the algorithm succeed? It goes through the flies from left to right. Started to find flies. Previous one counter example. This is the succeed. So wait. Not this one. I think this one, right? Let's check. Of course, it's correct. Why again? Yes, algorithm accepts A and B, all three criteria. Only these two not in conflict left to right accepted. Sort of like there's no shorter rejected one, so that's correct explanation as well as my final answer. Continue. This time is question number 5. Modify the algorithm. Complete line 2 to solve this instance of the problem. Again, 3 simple instructions, once again given as a repeat. Accepted to wait. Complete line 2 instance of the problem. Conflict with accepted one, so no accepted flag, shorter rejected one. It's not start and wait. By length, right? Let's see, I think it's yeah. Twice by length. Again, it's solved in length, so like not replaced by shorter rejected one. It should run properly. Let's check. Of course, this is likely correct. Why again? That's right. Let's scroll it down a bit. Yes, the original algorithm works when flights are ordered from shortest to longest. So we modify to sort the flights by length before loop starts. That's right. If I run again, this accepts. So only that. No other like shorter one. So ascending order by length. That's correct execution. Right, luckily correct this time, but I think there should not be no problem after all. But anyway, continue. This is question number 6. Analyze this algorithm. In what order does the algorithm consider the flies? Flies by length, then of course length. Find flies not accepted, conflict to accepted. So it's sort by length, not left to right, earliest or latest. So I think the shortest is F, FB, DCAE, right? In ascending order. This one, let's check. Of course, that's correct. Let's click on Y. That's right. Explanation tells us that since line 2 sorts the flights by length, the for loop runs through the flights list from shortest to longest, ascending order. F comes first since it's the shortest of all six, then followed by B, D, C, A, finally the longest one being E. Okay, simple problem, isn't it? Continue. This is question number 7, I reckon. Construct the schedule that this algorithm creates. Set the two flights by land. If not, conflict is that flight is that. How to select which one? Again, similar problem, so shouldn't be problem. Land, so I think this one. All others are conflicts, so they won't sort out. Let's check. The shortest three will only be executed. Of course, that's correct, luckily. Let's click on why. Yes, the algorithm considers meetings in the order F, B, D, C, A, and E. Same problem, so select only meetings F, B, and D. All other three conflicts with these three, so not selected. Anyway, continue. I reckon this is question number 8. Select the loop invariant. This algorithm doesn't sort the flights. Let's see why. Find flights not asserted. Every rejected conflict when asserted at least a short. Every rejected flight conflict when asserted flight. Invariant, like which one is it? Doesn't sort the flight, so yeah. At least a short. I think that one. Let's check. Uh-oh, it's incorrect. This one is correct. Let's click on Y. My bad. Line 3, 4 ensure every rejected flight conflicts with accepted flight. Oh yeah, like counter example. Since the flights aren't sorted, no guarantees about length. No way. I was a bit confused, like not this conflicts or like accepted flight. First time I got it incorrectly since I last recorded for some time, but anyway, let's move on, continue. Question number 9. Select the loop invariant. Algorithm sorts the flight reverse, largest to smallest. Oh yeah, fly in reverse, find flights. Not conflict, flight accepted, flight accepted. Conflict when accepted flight at least as short. Oh yeah, that's the opposite. Conflict when accepted flight at least as long. Let's check. That's correct now. Let's click on why. Yes, explanation tells us that line 4 and 5 guarantee that every rejected flight conflicts with a previously accepted flight, which must longer because the flights are sorted by reverse length in line 2. Oh yeah, line 2 has proved the evidence why that must be true here, right? Continue. Okay, question number 10. Select the counterexample. Prove that the algorithm doesn't solve this problem. Rejected flight accepted 1. Minimize to the duration of accepted flights. Few words. Fly by land. Find flights. Let's see. This one. Nope. This one minimized. But this one didn't, right? So let's check. Of course, that's luckily correct. Let's click on why. Yes. No. Here are the 3 statements and explanation. The algorithm accepts A and B, doesn't minimize total duration of accepted flights. A schedule with only flight C would satisfy all criteria, all 3 criteria, so not this third one. E and B, like total duration is way too long. If I close and compare this, like this is much shorter, so this one is a counterexample. Likely correct, right? Isn't it? I think probably the last question left to go, so continue. This is like question 11 or 12. Sorry if I got it wrong. Select the counterexample. Prove that the algorithm doesn't solve this problem. Oh, again, no conflict. Maximize number of accepted flights. But doesn't. Let's see. Fly by land. 1, 2, right? This is 1, 2, and 3. So the other one, so I think here, only 1. This is 2, so does not maximize. Let's check. Of course, correct again. Let's click on why. Oh yes, the explanation here would tell us that the algorithm accepts only A, which doesn't maximize number of accepted flights. With like a schedule with B and C will satisfy all criteria. Like only one accepted, but here like maximize accepted flights, but B and C will only satisfy because flight like selected from left only choose A, then reject B and C both conflicts. So counter example execute doesn't execute properly at all. So like counter example only sorted by line, like only one. These are like two steps. So this is counter example which execution will fail. Alright, anyway, I've luckily completed my level review. All questions in this algorithm chapter that I've presented to you, all but one question correctly solved. So I'll click this finish tab to conclude now. Yes, level complete again. So as a result of this level review completion with that final level of algorithm, I've gained 175 XP, experience points in total. Continue. No. Just skip this one. Ignore it. Wait a second. Alright, finally we're back in this algorithmic thinking chapter. You see this previous one, level review, I've completed, so mark with this hexagonal icon checkbox I mean, so lucky to get done. But here, just advanced to level 3, prioritizing early starts. First chapter is updating a strategy, something I want to record to you, but I don't have much time. Also, like, out of keys for today, so have to move to another day if I wish to return my activities on brilliant.org. Anyway, that's it all for this today's educational video that I've recorded, presented to all of you. So thank you very much for watching this, but I shall record this video somewhere around next time out, so don't miss it out. I'll just keep on track recording these videos. Anyway, bye for now. Take care. Cheers.